Hello, everyone. So, welcome to our first lesson of Unit 1. How exciting! So, we're going to be talking about functions here. So, our focus, and this is really just going to be an introduction through this lesson. We're going to focus on if you have a graph and maybe a little bit with a set of points. I might just more speak to that because that's something you've probably worked with in the past. I will successfully identify domain and range of both functions and non-functions. And keep in mind, I added this piece in where I said of both functions and non-functions because just because something is not a function does not mean that it doesn't have a domain and a range, right? It still has a domain and a range. Those are independent of each other. So maybe remember some things about how do you identify if something's a function? Maybe there was a way to do it if you had a graph, right? So maybe right now you recall something called the vertical line test. Maybe you even, I feel like I've seen people call it the VLT. It doesn't feel natural to me, but go for it. Vertical line test, right? So if it passes the vertical line test, it's a function, right? So if you can draw or if you can put your pencil down, I can't really show that right now, but if I could put a pencil down and move it from left to right across the entire domain, and it only ever touches the graph once, right? It only intersects that vertical line once as you're moving it, then it is a function. It passes the vertical line test. However, if at any point it touches the pencil more than once or the vertical line more than once, it's not a function. Right? So I use the word across the entire domain. Domain, if you recall, is the x values, right? So it's all the x values. Right? It might be written as an interval. Right? A lot of times I write it as an interval if it's a continuous graph. Whereas if it's just a set of points, that's what we refer to as discrete, and you would just have to list out the points in the domain. It doesn't include everything between them. So this is like the horizontal. So think moving horizontal. Think moving left to right. Whereas the range, you're going from bottom to top, right? So that's vertical, or it's your y values. And make sure that for both of these, you're going from smallest to greatest. So you're going from left to right, or you're going from bottom to top, right? You're not going from a positive value to a negative value. And for a lot of these, we're going to use what I refer to, not what I refer to, but what is referred to as interval notation. So that's what looks like, I don't know, -1 to 7. That's an interval. And we'll talk more about these brackets if that's not something you recall or not something you're super familiar with. So amazing. Make sure that you are taking notes as we're going through this and adding this to your notes. So, right? Oh, look, reminder. Are you taking notes? Function or not. If and only if, so that's what that IFF stands for. If and only if, so that means it's a definition. It works in both ways. So if and only if every domain value results in a unique range value. The domain is the independent value or the horizontal axis, and the range is what we refer to as the dependent value, right? We control the x. That's the input. Y, or your range values, are your output. That's what happens as a result. So if and only if every domain value, so every x value, results in a unique y value. It's only a function if you have, go away. Every x has just one y. You can't have an x value that results in multiple y values because that would not follow the vertical line test. It wouldn't pass the vertical line test. So we see this right here. This is what we refer to as f of x. It's like y, but it's y for a function, so it's called function notation. You can see g of x, x of x, I'm sorry, not x of x, g of x, k of x, b of x, a lot of different things. So first of all, is this a function, right? If I Draw a bunch of vertical lines, right? Anywhere, it doesn't have to be on those. Does it pass the vertical line test? It touches it once, it touches it once, it touches it once, it touches it once. What happens right here? Does it touch it twice? No, it doesn't actually touch it twice. It's just not continuous. It's like a removable discontinuity, which you'll talk about later on, but I'll still say that now. It doesn't, if I asked you what f of 2 was, your answer is 1. That open circle, means it doesn't equal to. A closed circle is equal to, right? So this doesn't exist right here. So this open circle, like there is nothing right here. It's like you go, woo, and then it jumps. And then it jumps back, and woo. Okay, so it does exist. It is a function. This does pass the vertical line test. Every x value just has one y value. You would never say right now that f of 2, when you plug in 2, your result is 2. So the domain of this is going to be from 1 to 3, right? It exists at 2. It exists everywhere between 1 and 3. So notice these brackets, these closed like box-like brackets mean that it's included because it's a closed circle. Sometimes you might see it written as 1 is less than or equal to x is less than or equal to 3. That works as well. I like interval notation a little bit more, but this works as well if you choose to write that. And then we've got the range. So this is from bottom to top. So this is not like you can have y can equal to 1, right? So think y can equal right here. And then it can equal from 2, not included, right? Not equal to 2, to 3, right? Or maybe you're going to write that as 2. Nope, it's not included. It's not included. Stop. 2 to 3, including 3. Right? So that could work as well. And there's different ways you could write it as like 1, comma, 2 to 3. There's a lot of different ways you can indicate that, and I'm not going to be picky about that as long as you're recognizing what is included and what's not. And that is an important concept for domain range. So I kind of just answered this over here. So f of 2, if you go over to 2 and you figure out where is the graph, where does the graph exist when x is 2, it's 1. This is asking you, given f of x equals 3, x equals, so we find 3 on the y. Oh, there's 2 answers. X could be 1 or x could be 3, right? And that's okay, right? It's just that every domain value has to result in a unique range value. It's not the other way around for it to be a function. Amazing. Okay, so let's take a look at this graph now. This is f of x. We've got a linear function. Oh, it is a function, right? It passes the vertical line test. What's the domain? Do we see these arrows? It means it keeps going. So the domain, we can write all real numbers, or you can write negative infinity to infinity, right? So this is not inclusive because you're never getting to infinity. Infinity represents that something is growing forever and ever, and it's getting really, really close, but it just keeps getting bigger. It never actually reaches it. Range, same thing. All real numbers or negative infinity to infinity. What happens now? Now I got rid of those arrows. Let me choose another color to write this one. What's the domain and range of this? Your domain, now it's going to stop somewhere, right? So now we're going to go from -6 to 8. Pay attention to just the x values. Or maybe you're going to write -6 is less than or equal to x is less than or equal to 8. Your range, go from bottom to top, is going to be -5 to 20. It's got closed circles. -5 is less than or equal to y is less than or equal to 20. But now this is going to get crazy. What happens now? Now I just changed that to an open circle. Let's pick one more color. what happens? Now your domain still goes from -6 to 8, but it doesn't include 8. I can write -6 is less than or equal to x is less than 8, right? We never actually touch 8. It doesn't touch it. The range, similar idea, right? It goes from -5 to 20, not including it. So notice that difference. Or -5 is less than or equal to y is less than 20. Right? So just pay attention to how those changed. So if we go back to the original function, so the equation of this line is 2x plus 5. So if we want to figure out what f of 3 is, this means that you're not multiplying here, right? I'm not doing this times 3. Be careful with that. I'm actually substituting. This is saying, well, when x is 3, what is the result? This is my input or my domain value. So I'm going to say 2 times 3 plus 5, and I would get yourself in the habit of showing your setup, right? This is demonstrating that you know what you're doing. You're not just writing an answer. And then, because this is not something that you necessarily need to be pulling out a calculator for, right? So f of 3 equals 11. I don't care about this step. You can get rid of this step. I don't need that. But I should be seeing stuff like this when you're being asked to show work or when you're being asked to actually solve this by hand. Same thing here. Given f of x equals 10, so I know that the result of f of x is 10, find x. So I'm going to show that setup. I'm going to solve it. 2x equals 5. So x is going to be 5/2 or 2.5. I like fractions. Amazing. Let's look at another one. Here we've got a quadratic, a parabola with a vertex at 0, 4. It is a function, isn't it? It passes the vertical line test. What's the domain and the range? Well, the domain, it keeps going out. There's no limits to what I could say x is. So that's what we refer to as all real numbers. Or you can say negative infinity to infinity. But the range is not all real numbers. This should definitely, that is not 0, 4. That is going to be 0, -4, isn't it? So it's going to go from -4. There's no closed circle here, but it equals to that. That is a point. Like if I wanted to put a point, it's going to be a closed point. Right? So it equals to it. -4 to infinity. Or if you want to say y is greater than equal to -4, that works as well. I think those are really the two that I would go with. What happens here if I put some endpoints? Right, so now this ends. I'm restricting it. That domain is now going to be from -4 to 4. Right, I took the arrows away. It doesn't keep going. The range is still going to start at -4, but it's going to stop at 10. Right, and if you want to try to write it and you want to say -4 is less than or equal to x is less than or equal to 4, go for it. -4 is less than or equal to y is less than or equal to 10. Amazing. That works as well. What happens there? Did you guys just see that? I had a closed circle and then, oh, it changed to an open circle. What does that do? What's that going to change? Does it change both the domain and the range? It's only going to change the domain, actually. Right? Because when you go up here, it still exists. Check that out. Like, you still have an actual closed circle when y is 10. It just isn't 2. Right? Here I had 2 of them. So the domain, I'm going to go from -4 to 4, not including it. But the range is still going to go from -4 down here to 10 up here. It includes it, right? At 10, it does exist. It just doesn't exist in 2 places. So let's go back to the original one. The equation of this parabola is x squared minus 4. If we want to figure out what f of 3 is, we're going to substitute that in and we're going to show it. Right? So this is going to be 9 minus 4, so we're going to get 5. What about f of x equals 3? And we should only get, as long as it's a function, which I'm using function notation, but as long as it's a function, we should get just one result when we substitute something in for x. that's not necessarily true down here, right? Let's think about if we went up to 3, I get 2 results. So let's see what happens. This means that this function is going to result as 3. So I'm going to say x squared minus 4 equals 3. When we go to solve this, I'm going to add 4, x squared equals 7, and then take the square root. Well, it can't just be the square root of 7. It's going to be plus n minus the square root of 7. Right? Whenever you take the square root of a number, it's the positive and the negative version. If the square root was already there, it's different. This is solving. You're using square roots to solve, and you're the first one that ever drew it. You get positive and negative, right? And we know that from here. If we went up to 3 and out, this is going to be positive root 7. This is going to be negative root 7. Right? So I get 2 results here. 7 is not a perfect square. Oh, what is this? Maybe you worked with these in geometry. This is a circle. So is this a function? No, I shouldn't be using f of x. Right? If something's not a function, it's just y. I'm not going to use f of x. However, it still does have a domain and a range. Right? So let's see, what's the radius of this circle? 1, 2, 3, 4, 5, 6, 7, 8, 9. Your radius is 9. Maybe you remember doing this in geometry, and if the center is 0, 0, you've got x squared plus y squared equals 9 squared, or 81. That would be the equation of this. Right? So maybe you did that with conics probably towards the end of the year, maybe around the time we left. But it does still have a domain. It goes from -9 to 9. And the range, I didn't actually count it, but it's a circle, so it should also be from -9 to 9, inclusive. Right? So even though there's no point, you don't physically see it, if I put a point here, it would be a closed circle. So it goes from -9 to 9, -9 to 9. Oh, look, we got the equation right. Woohoo! If x is 0, what's y? So 0 squared plus y squared equals 81. Y squared equals 81. Remember what we just talked about? We get that y equals plus or minus 9. When x is 0, that's right here, y is 9 or -9. And that is the reason it's not a function. I got 2 answers. Right? My unique domain value has 2 range values. That's not a function. What about when y is 3? X squared plus 3 squared equals 81. X squared equals plus 9 equals 81. Subtract 9. What is that? 72. And the square root. So you get x equals plus or minus the square root of 72. I'm going to go ahead and simplify that because I think that is a great scale. So x equals plus or minus, this is what, 9 times 8. So there's going to be a bigger one. 16? No. 36. What am I thinking about? It's 36 times 2. X equals plus or minus 6 root 2. Right? And if you don't successfully simplify it, this is fine. It is just good to know how to simplify because answers can be represented differently. And if you are picking an answer, knowing that the square root of 72 is the same thing as 6 root 2 is going to be very helpful to you. So that means when y was 3, this point right here is actually going to be 6 root 2, 3. And this point over here is going to be -6, why do I keep putting a comma? Root 2, 3. That idea. Amazing. So I'm going to kind of go through these quickly. This is kind of the end of the video, and if you haven't paused at all, maybe think about pausing and trying these. This is like the real, do you get this domain and range stuff? So you're drawing a picture that can fit this domain, right? So this saying the domain is all real numbers. It goes from -infinity to infinity, and the range is -7 to 7. 1, 2, 3, 4, 5, 6, 7. So it goes from here to here. Let's see, can I come up with something? it's got to have arrows, and it's got to include that. So maybe I'm going to do something like this. Woo. There you go. That works. There's an option. You don't want these to be asymptotes if you're someone that's aware of asymptotes. I could also have done something like, I'm going to clear this. Can I clear it? Reset? Nope, nope. That's not how you do it. I don't even know how you clear. Oh, okay, that was quick. I guess I could have also done something where it was like oscillating between the two, and it did something like this. You just gotta make sure that it's touching it. And I don't know, maybe it's like, you can have fun with it. You just want to make sure that this isn't like it keeps going back and forth. It could look like a sine graph if you know what those look like, yeah. What about this one? The domain this is integers, right? And the range is from 0 to 6. So it's just 0 to 6. But the domain is just integers. So let's see. Oh no, you're gonna have to have some, it's not gonna be a function, right? I might have to have some sort of like step function. Right, something like this, where I'm including all just integers. Oops. But I'm like missing, I messed that one up. This should go from here. I guess these could be bigger, but that idea where it's something like this. I'd be curious what you guys would come up with. Let's do 2 more. All right, so let's see this one. I don't love that notation, but that's okay. So my domain is all real numbers, right? Negative infinity to infinity, and the range is going to go from negative 2 inclusive to infinity. So it's not going to go, it's going to like touch this. I don't know, you can do like a parabola of some sort. It doesn't have to be right there. I could have moved it anywhere. Let's see. This one, the domain is greater than or equal to 2. Here's 2, but it's not going to be equal to 4. Okay. And the range is going to be all real numbers. So can I do something like, oh goodness. Oh no, it doesn't say that it's a function. So this is where it's not equal, so I'm going to put a hole, I guess. Oh no, and I can just move this over here, can't I? It doesn't say it has to be a function. And then since the range has to be all real numbers, I probably have to do the same thing here. And I'll stick this one over here. Oh no, I think that fits it, doesn't it? The domain doesn't equal to 4, but the range is still all real numbers. There you go, there's an option. Okay, so you can have fun with those. You can try them out. It's like the real test of, do you get this domain and range stuff? Can you do it in reverse? So your job now is to practice this and make sure you've got these concepts. And when you're ready to go ahead and do the post-lesson check for understanding posted on my MCPS classroom. And I do want you to keep in mind that feel free to use your notes. However, I would like for you not to use a calculator, and I would like for you to take this seriously, right? This is an opportunity for you to really give us, your teachers, some information about what your level of understanding is. And so if you're not taking it seriously and you're getting help from someone outside of yourself, we're really not seeing what you need to work on. So just keep in mind that it's not a grade. You will see right after what you did right, what you did wrong, what the answers are. And it's really going to be on you to just make sure that you're not sharing that information or you're not taking that information from somebody else. Because we do hope that this will provide us information to support you as we move forward. So thank you for all of that. And if you need to go back and rewatch anything, feel free to. Also feel free to reach out with questions or post them on the discussion board. Thanks, everyone.